Chapter 8, Day 9, we are going to work some more on factoring, and especially some maybe more challenging types of factoring when we're factoring a quadratic trinomial and a is greater than 1. So let's just start a little bit with factoring. What does it mean when I say factoring? Or when I ask you, what are the factors of 10? Well, hopefully you can tell me that the factors of 10 are 2 and 5, because 2 times 5 equals 10, or negative 2 and negative 5, because factors are the two numbers that get multiplied together that equal a product. And 2 and 5, or negative 2 and 5, are not the only factors, because 1 and 10 are also factors, or negative 1 and negative 10 are also factors. So when we talk about factoring, it's really the process of finding factors. Okay? So when I ask you, what are the factors of 2x squared and negative 6x, I'm asking what times what would equal this product. And whenever we start with factoring, the very first thing we should always look for is to see if we can find a greatest common factor, because then we can divide out the greatest common factor and multiply it by what is left, and those will be our two factors. So in this case, this particular problem does have a GCF of 2 and x, because 2 goes into each 2 and 6 evenly, and there is an x in each one of these. Now there are 2 x's in the first term, but only 1 x in the second. So that's why there's only 1 x that's in common to both terms. That's why the 2 is common to both 2 and negative 6, because it is the only number that divides evenly. So our GCF for this would be 2x. So 2x times what is going to equal 2x squared minus 6x? Well, we can find that other factor by dividing by 2x, by dividing by that greatest common factor. And when I take 2x squared and divide it by 2x, I get x. And when I take negative 6x divided by 2x, I get minus 3. And because that's a binomial, we usually put that in a parenthesis. We could have parentheses around both of them if you want, but those are our two factors that give us the product of 2x squared minus 6x. So that's just a little bit of an overview of factoring. So here's a warm-up of some of the ones that you should be able to factor already from what we've already learned. So why don't you pause the video, try as many of these as you can, and then restart the video to see if you got them correct. Every single time you're asked to factor, we always look for a GCF. And so you're looking for a number that goes into both 12, 4, and 8. Well, 4 goes into each of those. But then you also have to look for any common letters. There's a D here, a D here, and a D here. There's E's in 2 of the 3 terms, but not the third. So there is only 1 D in common, because again, there are 3 D's in this term, there are 2 D's in this term, and only 1 D in that final term. So there's only 1 D that's in common. So our greatest common factor is 4D. So then our answer is 4D is one factor times the other factor. And remember, we get that second factor by dividing by our GCF. So when we do that, we would get 12 divided by 4 is 3, and then D to the third divided by D to the first is D to the second. We subtract those exponents. Negative 4 divided by 4 is negative 1, or just D, E, and then 8 divided by 4 is 2, so we get plus 2, and the D's cancel out because that's 1, and you get 2E squared. So that is factored. Now once we get to this part right here, sometimes we need to look inside that second parenthesis to see if it can be factored some more. Okay? Usually we're looking for just quadratic trinomial where a equals 1, so we're going to stop there on that one because it doesn't have any common letters as well. It doesn't fit the form. Okay, so when we look at the next one, there is no GCF. So notice, though, that this is in the form where we have no number in front of our variable squared. It is a quadratic trinomial. Quadratic meaning it's degree 2, trinomial meaning there are 3 terms. And when the number in front is a 1, then we can use the simple strategy of finding 2 numbers that multiply to negative 30 and that add to 7. So you start listing and thinking of the numbers that multiply to negative 30, and then you see which ones add to 7. So oftentimes you're going to think of 6 and 5, but remember one of those numbers has to be negative. But neither of those combinations add up to positive 7, so I try some other ones. Oh, I remember that 10 and 3. But again, one of those would have to be negative. Oh, now I found it. I found that 10 and negative 3, when I multiply them, I get negative 30, and when I add them, I get 7. So those are the numbers that go in the parentheses, because whenever we multiply the last term times the last term, it's always going to give us this last term. And whenever we multiply the first term times the first term in these binomials, it's always going to give us this first term right here. So it has to be y and y. When there's no number in front of the 10 or the number that you put in the back, that means it's a positive. And so then this is your answer right here. Y plus 10 times y minus 3. Now, if you're wondering, how do we get the 7 when we would multiply that to check? Remember, the 7 is coming from when we multiply these outside terms together. That gives us 10y, and the inside, or sorry, that gives us negative 3y, and 10 times y is 10y, and we add those together, that's what gives us the 7y. That's what gives us this 7y. Okay, now this third problem does have a GCF. The third problem has a GCF because there's a 2 that goes into each. So my problem is going to look like 2 times, and then what I put in the remaining is when I divide by the GCF, which would give me x squared minus 7x minus 30. Now, this is different from the one we did at the top because that was not a quadratic trinomial. But when we look at this one, we have a quadratic trinomial. So actually, we can try to factor this like we did in number 2. And if you notice, the numbers are very similar. So can you think of 2 numbers that multiply to negative 30 that instead add up to negative 7? Well, that would be the opposite combination of negative 10 and 3. So I put in the negative 10, I put in the plus 3, and I put in my variables with it. And so now this expression is completely factored. All right, last but not least, this last one also has a greatest common factor. The greatest common factor is 2. Again, so I'm going to divide by 2, and that's going to give me 2 times x squared minus 25. Now that does not look like a quadratic trinomial, but it really is, because we have a quadratic, and our trinomial part, we don't have a middle term, but we could have rewritten this as x squared plus 0x minus 25. And so this type, we are still looking for 2 numbers that multiply to negative 25, but they add to 0, and that was where we would get 5 and negative 5. So completely factored, this would be 2 times x plus 5 and 2 times x minus 5. Now I know some of these are getting pretty complicated, but many of you are ready for those additional challenges. So in the last video, I showed you a little clip from a video of Uptown Factors to help you remember the multiply and add up. So you can type in that and search for that yourself. I'm not going to play it in this video as well, so you can go back to the video from day 8 if you would like to see that. But let's see if you can try these two questions that are quadratic trinomials, quadratic trinomial, where the number in front of x squared is 1. And whenever we have that, we can look for multiply and add up. So go ahead and pause the video right now and see if you can try these two and see if you can get them, and then restart the video to see if you got them correct. Okay, your answer for the first question would be -2 times -3 multiplies to give you 6 and adds up to -5. And in the second one, you would have -8 and +3 that multiply to -24 that add up to -5. So what about something like this? Notice now that your a value is not 1. And if you try to find two numbers that multiply to -5 that add to -2, you won't find them, because 1 times -5 or -1 times +5 are the only factors of -5. Well, the problem is they're not going to add up to -2 because of this 3 in front. So this is not really the strategy we can use here. But we do know from what we'd learned before that the first term times the first term always has to equal this first term here. That is true from the ones we did in the past as well. So that means the only way we can get 3p squared is multiplying 3p times p. So I know that's the beginning part. I also know that the last term times the last term always has to equal -5. So that's one of these two combinations. So I'm going to try this combination first, and I'm going to put in +1 and -5. Now, I'm going to check it, okay? I can see that the first terms and the last terms work, but I need to work on the outside and the inside terms. The outside term would give me -15p, and the inside term would give me 1p, and when I add those together, I am looking for -2p, but that does not work. That would give me -14. So now I'm going to try them in the opposite order. So I'm going to switch the order around and put -5 here and +1. So now when I multiply 3p times 1, I get 3p. When I multiply -5 times p, I get -5p. And these added together does equal -2. So those are the numbers that I am going to put in to my parentheses. So I'm going to go back, and now what I have is 3p minus 5 times p plus 1. And that is the combination that works. And that process is called kind of guess and check. And that's not too bad when you have small numbers for your first and last terms. But as you get more combinations and as you have to keep trying to switch them, it becomes quite a bit of guessing and checking, which isn't bad, but it just takes some time. So there are other ways to factor. One way we looked at in the past is the box method. Now, I have gone through the box method several times already on videos. But some of you like to multiply with the box, so I'll show you one more time so you can see the difference between multiplying using a box and factoring using a box. So here's what we need to do. We need to write the trinomial in the diagonal. Okay, so I take this and I write it diagonally. Okay, then I find the product of ax squared and c. So ax squared and c is going to give me, so 3x squared times -5 gives me -15x squared. Now I find factors of -15x squared. So I am going to take negative 15x squared and find factors. Well, it could be negative 3 and positive 5, or positive 3 and negative 5. Those would all multiply to negative 15. But remember, it has to add to this term in the circle right here of negative 2. So this is the combination that adds to the negative 2. So again, I could put the x's with that, which would give me 3x and negative 5x now. And those are the numbers that I'm going to write in the other two boxes. So I have 3x and I have negative 5x for the other two boxes. So the last thing I do is I factor out the GCF from each row and column. So what I'm talking about here is from this column right here, there's a GCF of 3x. So 3x is the GCF. From this row, this column, there is a GCF of negative 5. So I'm going to write that up here. Then I'm going to do the same thing for the columns. Those were the columns, the rows. So what is the GCF of 3x squared and negative 5? Well, there's no number, but there's an x in common. So I'll factor out an x. And my last row down here would be this one. And there is no greatest common factor except 1. So now we just take those and write it inside the parentheses. So we would write them as 3x minus 5 and x plus 1. So if you go back, this was the same question we did on the previous example of guess and check, and you can see that it's the same except the variables. So there's a third method that has become quite popular and is just one more way of thinking about this. If this makes more sense to you, you should probably use this method. So another method, I don't really have a name for this yet. Several of the other teachers are using it, and everybody kind of has their own name. So I'm not going to actually name it yet. But what we're going to do is we're going to do the same thing we've kind of been doing, is multiplying ax squared and c. So 3x squared and negative 5 gives us negative 15x squared. Okay? I'm just going to put the negative 15, just the number up there. So now I'm looking for factors of this right here that add up to b. Okay? Remember, b is this middle term. So 5 times 3 would give 15, but negative, one of them would have to be negative. Well, I already found the combination that works. So this is the combination that works. So now I put those factors as the last term in each parenthesis. So I'm going to put negative 5 and positive 3. This is similar to the other ones we've been working on. But now I am going to put ax as the first term in each parenthesis. So my a is 3 and then an x. So I'm going to have 3x and 3x. Now the problem with this is if I multiply 3x times 3x, it does not give me 3x squared, it gives me 9x squared. So this is where it becomes kind of a problem. And so what we do to eliminate the problem is it seems kind of like unnatural maybe, but we're going to divide each parenthesis by a GCF if there is one. Well, there is no GCF between these two terms, so I'd just be really dividing by 1 or not dividing at all. If I divide this by a GCF, a 3 goes into each one, so I divide each term by 3 and I would get x plus 1. And again, we are getting the same exact answer that we got doing it in the method in the box or doing it with guess and check. So 3 different methods, okay, to solving a quadratic trinomial where a value is greater than 1. So this is when a is greater than 1. If it's equal to 1, just use multiply and add up. So let's do this third method one more time with another problem. Okay, now I don't have the directions written down. okay? But what I need to do is I need to find this product. So negative 9 times 2 is going to give me negative 18, okay? I could put the n squared there, that's fine. But I'm really looking at factoring these. So I'm looking for two numbers that multiply to negative 18 that are going to add up to 3. Well, 6 times 3 is 18, but one of those would have to be negative. Okay, well, the bottom one right here, this adds up to positive 3. So those are the numbers that I put in the parenthesis. So I'm going to draw my parenthesis, and I'm going to put the 6 and the minus 3. So what's different here is I'm not going to put 2n and n first. I'm going to put 2n and 2n. So whatever this a and then the variable is, that's what we put in there. Now I'm going to divide by the GCF. So is there a number that goes into both? Yes, 2. So I can divide by 2, and that would give me n plus 3. Is there a GCF here, a number that goes into each? No. So I'd really be dividing by 1, which doesn't change it. And there we go. So there is our factored form. Now, again, you can choose any of the methods that we've done, and it's confusing, I know, to some to have a bunch of different methods, but maybe try each one, see which one makes the most sense to you, and then continue to use that from there on forward. All right, so here's one that you could try on your own using one of the methods that I have shown you, and then you can check the notes to see if you've gotten it correctly. And I will put the notes, I will put not only the answer in, but I will put probably at least one or two of the factoring strategies and methods to show you how we got that. I'm not going to probably do it for all three, okay? But I will show you at least one or two of the methods. Now, remember as you're doing your homework to make sure you show me your work so I can see what method you're using. I will make an additional video later on with talking about another method that we've used a lot in the past that students have liked called the snowflake method. I'm not going to highlight that one in class because we already have 3 other methods to solve. But this is the end of our video for